In this tutorial we're going to take a look at, well, we're going to have a kind of overview of C, C++, C#, Objective-C, and also Java, which Java doesn't have C in the name, but in a way it probably should. So back in 1973, I don't really keep these facts in my head, not all of them anyway, so I've relied somewhat on Wikipedia here. But back in 1973, an American programmer by the name of Dennis Ritchie created a language called C. I think there were languages floating around called A and B, I'm not sure about that. But C was created and it proved to be very popular. Now C is based on functions, so if you've been following this course on C++, you've already seen functions. But we've seen that in C++ we can also use classes. C doesn't use classes. Classes were a later development. Object orientation was a later development. So they weren't, maybe they were around, I don't know, when C was invented, but they weren't incorporated into C at least. And C is still used today, and there are various reasons for that. One reason is that C is even faster than C++, because the object orientation, the classes, they add some overhead to the language, which isn't going to make any significant difference for most programs. But nevertheless, C programs can potentially run faster than C++ ones, at least under some circumstances. Well, of course, a major determinant in the speed of your program is just how well written it is. So people are still using C, especially for very low-level applications like device drivers and stuff like that. Also, I suspect if you've been writing C code since the 70s, you don't necessarily want to go on and learn C++. You want to carry on using what you're using. So sort of tradition and inertia also come into it, but C does still have its place. Now, moving forward to 1979, a Danish guy whose name I can't properly pronounce, so I'm going to call him Bjarne Stroustrup, developed the C++ language. C++ added on classes to C, so it turned C into an object-oriented language. Object orientation was still around, was around previously, but it didn't exist in C. So he developed C++ and it became a great success. These languages, they're all sort of continuously being upgraded and developed. C++ new standards come out and people implement those new standards. But the original version was was created by this Stroustrup guy, whose name I'm sure I'm mangling. And it was like classes had basically been added to C. Now, no one seems to know exactly quite where the name C++ came from, but there is a book by the British author George Orwell called 1984, and that was written in 1948, and Orwell envisages 1984 as being a sort of communist, highly controlled dystopian society, where the government even controls language. And in 1984, if you want to say something's really good, you add plus after it, so ice cream plus is good ice cream. If you want to really emphasize how great something is, you add plus plus, so ice cream plus plus. Therefore, there's this idea that C++ maybe got its name because it's C++ in the lingo of 1984. Of course, it's also true that there's the increment operator plus plus in C++, which we've seen in this course. So maybe it was even a conjunction of these two things that inspired the name. A thought occurred to me last night while I was thinking about this lecture. Can't Bjarne Stroustrup answer this question once and for all? I don't know who gave C++ its name, but I've never heard anyone give an answer with any certainty as to where the name came from. So C++ is C with classes. And it kind of changes a lot of things in C, but with a few minor differences, you can generally compile a C program using a C++ compiler, you might need to enable some special options there. But C is really kind of like a stripped down version of C++ in many ways. I think there are some things in C that don't exist in C++. Some things you can't do, but they're very few. So whereas with C we're using functions as the kind of organizing entity in our programs, in C++ we're bundling those functions into classes together with data, and we're using those to organize our programs. And C++ has proved to be extremely popular, of course, which is why I've made a course on it. Now, winding forward to 1995, Sun Microsystems, which is now owned by Oracle, developed this language called Java. A lot of people felt that C++ was too hard, basically, and not only too hard, but it was really easy to create bugs in C++. And on top of that, a C++ program has to be recompiled for every new platform that it's going to run on. So if you take a computer program and you want to run it on a different platform than what you wrote it on, like for example, maybe you wrote it on PCs and you want to run it on Apple Macs, often you have to make code changes there because you're, for example, creating windows in different ways or whatever. But even more than that, with C++, you have to actually recompile the files to a binary format for your new target system. So Java addressed some of these problems by Java has a thing called a virtual machine. So there's kind of basically a simulated computer running on top of your existing computer, and that means that the Java binaries, the Java class files, we call them Java compiles to these class files. They run actually on the virtual machine, the simulated computer, not directly on your computer. So that means you don't necessarily have to recompile a Java program to get it to run on a new platform. There are disadvantages of that as well. Well, actually, I should mention another big advantage, which is that Java is much less prone to bugs than C++. Because the virtual machine can do a lot of checking. It can check if you run off the end of an array, and Java has a thing called the garbage collector that frees memory you've allocated, so you don't have to deallocate memory yourself, and memory deallocation is a big source of bugs in C++. But then you get disadvantages as well, like the virtual machine means that Java runs more slowly than C++ programs. Of course, it's always possible to write a really badly coded C++ program that runs more slowly than a Java program, but other things being equal, Java runs more slowly than C++. Whether you actually notice that in the application that you're using depends, of course, on what the kind of level of demand is that you're putting on your machine. But Java is inherently somewhat slower than C++. So we get advantages with the virtual machine. We can just take the class files often and just run them on a different computer, because that computer will have an implementation of the virtual machine written, I guess, in C++ probably. And then the actual Java class files, they just see that virtual machine, and they can just run on that without any change. But then it's slower. So Java is an easier language to learn than C++, I would say. I've got a huge free course on Java at caveofprogramming.com, and it's easier to learn, and it's become very, very popular, partly because of the portability, partly because of the ease of use of Java. It's really designed to be easy for the programmer to work with. I did a search on jobserve.com a while ago, and I think the results were something like, in the US, I turned up something like I think it was like maybe 3,000 jobs for Java at a given moment, and something like 2/3 as many jobs for C++. So Java is not replacing C++, and we'll go into that a bit more later. but it has taken over a lot of the things that C++ would have been used for at one time. Now, C# was developed by another Danish guy whose name I'm also going to horribly mangle, Anders Hejlsberg, sometime around 2000 or so. He was working for Microsoft, and C# is a Microsoft language, basically. So again, C#, I believe, uses a kind of virtual machine as well. So it's not the fastest language in the world. It's not got the speed of C++, as far as I understand, and as far as I can tell from having written some programs in it. And it's closely associated with Microsoft. It's basically used for programming Microsoft Windows, or it can be used to create websites as well, but it's tied pretty much to Windows. Although people have implemented the .NET platform for Linux, for example, so you can use C# on other platforms, but it is very closely associated with Microsoft. On Microsoft, if you want to write C# programs, you can use Visual C#, and there's a Visual C# Express at the moment, at least, which is free but a bit limited, especially when it comes to creating installers. Although my information on that could be out of date there. And a similar IDE, Mono, has been implemented for other platforms, but last time I checked it out a couple of years ago, it's now towards the end of 2014, Mono was kind of a bit primitive looking. So if you use C# on Microsoft Windows and you're happy being tied to Windows, you can use Visual C#, and it's a beautiful IDE to work in. You can create programs with a nice visual designer. It's really great, but you're stuck with Microsoft, and again, because there's like a virtual machine in there, some kind of virtual machine. I'm not so sure that it's so easy to access low-level facilities of your computer in C#, and again, that's another reason why you might want to use C++ instead. And yes, you've got some issues of slowness which won't necessarily be noticeable in your final program, but they are kind of there. Objective-C I've never used at all, so I'm relying on Wikipedia for this. But apparently in the 1980s, Brad Cox and Tom Love, working for Apple, the Apple Corporation, developed a language that was, I believe it's again kind of based on C++. So Java is strongly based on C++. This is something I don't think I mentioned but should have. Java looks a lot like C++, and if you learn C++, it's not a huge stretch to go on and learn these other languages. Similarly, as far as I know, Objective-C is also ultimately based on C++, and it's closely associated with Apple. Again, I believe there are implementations of it for other platforms, but basically you can pretty much think that you're tying yourself to Apple if you use Objective-C, which is fine. Objective-C, I believe, uses some kind of lightweight virtual machine, but I'm not going to speak much more about that because I don't really know. I don't really understand Objective-C. I haven't used it. So again, you may even on an Apple Mac, you may well want to use C++ for the speed and the power, but it's a good choice, Objective-C, I guess, if you want to write kind of real Apple Mac programs that look like they're being developed for the Mac. So now you might be wondering, we've got Java, we've got C#, we've got Objective-C, we've got lots of other languages that I haven't mentioned. Is C++ some kind of anachronism? That is it something that's just hanging around because out of inertia, because people don't want to learn new languages or whatever? And the answer to that is emphatically no. There are kind of almost as many C++ jobs around as Java jobs, less I would say, but still a lot of jobs for C++. And the reason for that is that we just can't do without it. C++ is still being developed. Recently we've got C++ 11. I believe that was developed in 2011, which is where the 11 comes from. In this course so far, I've been teaching basically C++, I guess, 98, from 1998 onwards. C++ hasn't changed that much, and as far as I know, the 11 version, it's not a radical overhaul, but C++ is being continually revised and it's being still used. And the reasons for that are the ones that I've mentioned. If you want a program that runs as rapidly as it possibly can and can access all the facilities of your hardware, even in ways that no one's thought about before perhaps, even if you're using completely new hardware that you may even have just invented yourself with your computer, and if you don't want to use C, you want to have the luxury of classes and object orientation, then you need to use C++. And that's not looking like it's going to change anytime soon. Very high-end games are usually written in C++. Very, very powerful, innovative artificial intelligence programs are liable to be written in C++, because anywhere where you need to squeeze as much power out of your computer as possible, anywhere where you're at the cutting edge of software development, you're going to think about using C++. It gives you that power, it gives you that speed. So C++ is well worth learning. Okay, it's difficult, but then an advantage of that is when you've learnt it, other languages sort of seem easy. Yes, to learn Java after C++ requires certainly some effort. You're going to have to put some effort in there to learn new syntax, but these other languages, as we've seen, are heavily based on C++, and they're all, I would say, kind of easier, the ones I've used at least, than C++. So for all these reasons, C++ is a very great and important language to learn, and it's going to be important, I suspect, for a very long time into the future. Okay, so that's it for this tutorial. If you've been following this course so far, I'm planning to add probably just one more video, and if you have followed this course from the beginning, this is a free course on C++, or if you're watching it on Udemy or somewhere in the future, I may well have bundled this with a more advanced course to create one massive non-free course. But if you followed it from the beginning, then yeah, big congratulations. And we're going to kind of wind up this course in the next tutorial. So I've given you an overview here, but I don't have an in-depth knowledge about how all these different languages work. I feel on solid ground pretty much with Java and C++, but C# and stuff, my knowledge is less good. So if I've said anything in this video that conflicts with what you already know, it's quite possible that I'm just wrong. But I think this is basically a reasonable overview for someone who is just wondering what the heck all these different languages are. Okay, so